In this video, I'll be showing you how to add fractions with unlike denominators. When adding fractions with unlike denominators, you want to make sure that you have a common denominator. Here is an example. In this example, the denominators are 8 and 4. We can see that they are different and we need to make them the same. To find the common denominator, we would take 8 and we would take 4 and find out if any of the sequence will have a common denominator. So for 8 times 1 is 8, 8 times 2 is 16, 8 times 3, 24, 8 times 4, 32. Okay, now for 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. If you see a number that is common for both numbers, then you can stop there. In this case, we see 8 and 8. So we can stop here and determine that our common denominator is going to be 8. So what do we do next? In this case, we see since the denominator is going to be 8, the first fraction is already 8. So I'll go ahead and times this by 1, and when you times the denominator by 1, you need to times the numerator by 1 as well. And for 4, we need to times that by 2, and 4 times 2 becomes 8, and the numerator also needs to times by 2. Okay, so we can rewrite this as 5 over 8 plus 2 times 2 is 4, 4 times 2 is 8. Now we have common denominator, and now we can solve this question by taking 5 plus 4 over 8, and that equals 9 over 8. Now what about this question? Again, we're gonna look at the common denominator first and do the same thing as previous example, where we're gonna multiply them, the sequence of numbers. So 12, 24, 36, 48, and for 8 will be 8, 16, and we'll stop whenever we see one that matches, 24, and in this case we can see 24 matches here and here. So now we can solve this equation by making the denominator 24. So for 12 to be 24, we will times that by 2, and denominator times by 2 means the numerator also needs to times by 2, and for 8 we need to times that by 3, and the numerator by 3. Okay, and 4 times 2 is 8, 12 times 2 is 24, plus 3 times 3 is 9, 8 times 3 is 24. Okay, now we have the common denominator 24 on both. We can go ahead and solve this equation. And so 8 plus 9 over 24 equals 17 over 24. And there's your answer. In this video, I'll be showing you how to subtract fractions with unlike denominators. The first thing we need to make sure of is that they have a common denominator before we start the subtraction. In this example, we have 5 and 15. To find the common denominator, we will write sequence of numbers and see if any of them matches. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. For 15, 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45, 15 times 4 is 60. We can stop as soon as we find a common denominator. In this case, 15 and 15 here, they both match. To solve this equation, the denominator needs to be 15 for both. So for the first fraction, 8 over 5, the denominator of 5 needs to times by 3, and the numerator also needs to times by 3. For the second fraction, the denominator is already 15, so we would times this by 1 and the numerator by 1. Now we can rewrite it like this. 8 times 3 is 24, 5 times 3, 15, minus 2 over 15. Since now the denominator is the same, we simply take 24 minus 2, and that gives us 22 over 15. And that's our answer. Here is another example. We will find the common denominator of 4 and 20. Again, we'll go ahead and write out the sequence of numbers. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. And for 20, we have 20 times 1 is 20, 20 times 2 is 40. But wait, we already found the common denominator. So now we need to make the common denominator 20 for both fractions. So the first one, we will times by 5 to get to 20, and the numerator by 5 as well. And for the second fraction, it's already 20, so we just need to times by 1. And to rewrite this, we would have 45 over 20 minus 4 over 20. And taking 45 minus 4, we will have 41 over 20. And we can also rewrite this as a mixed number of 2 and 1 over 20. And that's our answer. In this video, I'll be talking about multiplying fractions. Here is an example. In this basic example, we're simply having 3 over 5 times by 4 over 6. So we're just taking the numerator times the numerator and the denominator times the denominator. 3 times 4 is 12. 5 times 6 is 30. Now we can see 12 over 30 to be both divisible by 2. So the answer that we would have, 30 divided by 2 is 15, and 12 divided by 2 is 6. So our final answer is 6 over 15. Here is another example. By multiplying the same method, 24 times 5, the answer is 120. Now if we times the denominator, 30 times 3, that would give us 90. We can further divide this both by 3. So we will end up with 40 over 30. Wait a minute. Now we can see the top and the bottom can both divide by 10. So let's do that again. So our final answer is 4 over 3. Looking at this example, we see that we simplify it quite a few times. So a good way would be to simplify before multiplying. So we're going to try an example where we are going to simplify before multiplying. In this example, 30 could be 5 times 6. And 45 could be 9 times 5. And 40 is equal to 8 times 5. and 10 will be 5 times 2. So here, we can see that we could simplify the 5 here, and then the 6 could be changed again to 3.2. And the 9 could be 3 times 3. So then we could simplify the 3 here. And same here, a can be changed to 4 times 2. So we can cancel out the 2. Now what we have remaining is 4, 2, 3, and since the denominator here are all crossed out, so we're left with 1. Then we just need to times them together. 2 times 4 equals 8. 3 times 1 equals 3. And we can't simplify anymore after this, so our answer is 8 over 3. Now let's take a look at the same question, but without simplifying. If we were simply to take 30 times 40, we would have 1200. And if we take 45 times 10, we would have 450. Now this looks like a big number to simplify after, so it would take multiple steps to simplify to the final answer. The numerator can divide by 10, denominator by 10, then we will have 120 over 45. Then we can see both numbers can be divisible by 5. Then we will have 24 over 9. Now 24 and 9 are both divisible by 3. And so our answer would result A over 3. Now this method works as well, but it's a longer process because then you have to divide the numbers multiple times rather than simplify before you multiply. Here is another example. By simplifying, we can simplify the numerator and the denominator, or we can simplify diagonally between the fractions. By looking at this question, we can see that the 6 and 24 are both divisible by 6. And the 60 and 20, they're both divisible by 20. Now that we have the setup ready, we'll go ahead and simplify before we multiply. So the numerator here will be 6 times 1. And the denominator will be 20 times 1. The 60 will be 20 times 3. Denominator here will be 6 times 4. Then all we have to do is cross them out and cross the 20 out. And then what we have left, we would times them together. 1 times 3 is 3. 1 times 4 is 4. And that's our final answer. Now let's try another equation with bigger numbers. At any time during the video, feel free to pause the video if you need time to calculate yourself before the answer is determined. Now by looking at this question, what do we see that can be simplified? I see that 55 and 25, they're both divisible by 5. And I also see 46 and 24 both divisible by 2. So we'll write out like this: 5 times 11, 5 times 5, times 2 times 2 times 23, 2 times 12. Okay, so we can cross out the 5, cross out the 2, and now we're left with and by multiplying together, we'll have 253 over 60. 253 over 60. Now this can no longer be simplified further, so this would be our final answer. Now what if you times the fraction by a whole number? The first thing we need to do is convert the whole number to a fraction. So in this case, 9 would be equivalent to 9 over 1. So we'll write 10 over 3 times by 9 over 1. And here we can see 9 and 3 can both be simplified by 3. So we'll write it. So we can write it like this. Okay. And we can simplify the 3. And that's it. Then we are left with 10, 3, and 1 on the bottom. So the answer would be 30 over 1. And then that equals to 30. Now let's try one where we're multiplying 3 different fractions. Now since there are 3 different fractions, it would be more difficult to determine what number to divide each of them by. Since there are 3 different fractions, we can simply just simplify the best that we can and then just further simplify as we go. So for 14, we know we can times that 2 times 7. And 36 would be 6 times 6. 24 would be 6 times 4. 50 would be 5 times 10. 21 would be 7 times 3. 33 would be 3 times 11. Now we can just kind of go through the numbers and see which one we can cross out. So the ones that I see is 6 and 6 here. Then 3 and 3. Now we can also further divide the number. Example, the 6 here could be 3 times 2. And the 4 here could be 2 times 2. And the 10 here could be 5 times 2. Then we could cross the 2 out. Cross the 2 here. And what we are left with is 7, 2, 7, 3, 5, 5, 11. And by multiplying them together, I will have 98 over 550. Now 98 and 550 are both divisible by 2. So our final answer will be 49 to 75. In this video, I'll be showing you how to divide fractions. Here is an example. When we are dividing fractions, we want to change the division to multiplication, and we want to reverse the fractions, the denominator to the numerator and the numerator to the denominator. So it would look something like this. Notice how we change from division to multiplication here, and we reversed the denominator and the numerator. Then the next step would just be multiplying them together. So we would take 5 times 7 and 2 times 3. So our final answer would be 35/6. Now at any time during the video, feel free to pause the video if you need time to calculate and get your own answer before we find out the answer. Here is another example. So we would do the same thing where we change division to multiplication, and then we flip the denominator and the numerator. So we would rewrite like this. Then we would just times them together, and that's our answer. Let's try another question with bigger numbers. Okay, so we know to leave this the same, change division to multiplication, flip the denominator and the numerator. Now let's look at this and see if we could simplify before we multiply. 24 and 2 we know can definitely divide by 2. The 37 and 11, there's nothing that you could simplify there. So we'll write like this. 2 times 12 over 11 times 37, 2 times 11. So we can cross out the 2. Then we'll end up with 12 over 11 times by 37 over 11. And our final answer would be 444 over 121. Now what if you were given a different format of division, a question that looks something like this? What we want to do here is rewrite the question. So this is equivalent to 46 over 81 divide by 28 over 15. After we've done this, then we know what to do next. So the same way as we've done before, 46, 81 times 15 over 28. Now we can try to simplify this before we multiply. We could see 46 and 28 both divisible by 2. The 15 and 81 are both divisible by 3. 46, we can get 2 times 23. 81, we know it's 9 times 9. Times 15, we know it's 3 times 5. And 28, 2 times 14. And from here, we can cross out the 2. And if we look at the number 3 here, we can see that it could cross out with a 9. So we'll change one of the 9 to 3 times 3. Then we can cross this 3 out with this one. Okay, now that we don't have anything else, let's see what we have left. So after we multiply them together, we'll have 115 over 378. Since we can no longer further simplify this, this would be our final answer. Now, what if we are dividing a fraction to a whole number? In this example, we need to first convert the 4 to 4 over 1. Then the next step should be easy. And from here, we can see 4 and 4. This can definitely divide by 4. So we can rewrite it. And cross out the 4. And we are left with 4 times 1 is 4. 9 times 1 is 9. And that's our final answer. Now, what if we are dividing a whole number by a fraction? Here is an example. Like the previous one, we have a whole number that needed first to be converted to a fraction. So we rewrite it like this. And then we want to change it to the multiplication format. We can see that 12 and 14 are both divisible by 2. So we can rewrite it like this. Now we can cross out the 2. And we are left with these. Then we just need to times them together. 6 times 9 is 54 over 7. And since we can no longer further simplify this, that would be our answer. In this video, I'll be going over how to convert fractions to decimals. Here is an example. 3 over 4. So we'll divide 3 by 4. 3 is not big enough. So what happened here is we'll put a 0 on top and put a decimal here. Now when we do this, we are now looking at 30 as the number to divide by 4. 30 divided by 4, we can use 7, which is 28, and this come out to 2. And then we'll bring another 0 down. And 4 times 5 equals 20. So the answer is 0.75. Here is another example. 7 over 16. Again, we'll divide 7, which is the numerator, by the denominator, 16. 7 is not big enough to divide by 16, so we'll put a 0, then we'll place a decimal point, then we'll put a 0 after it. And the reason why we can put a 0 behind the 7 is because the 0 value does not change the numerator value. So it's still 7.0, and it could be also another, you can add another 0 and 0 and 0, and will always still be 7. So in this case, we added the 0, and again, we're looking at this as 70. divided by 16, and 4 goes in it, and that comes to 64. 70 minus 64 is 6. Then we bring the 0 down, and we can see 3 goes into it. 60 and will come out to 48. Then 12 comes down. We bring the 0 down again. Then the next number is 7. Then we get 112. Then we get 8. And we bring the 0 down. And the last one's 5. And we get 80. And that's the final answer. And that is the final answer. Now the question might ask you to round to the 10th value, the 100th value, or the 1000th value. So in this case, if they ask you to divide to the 100th value, it will be 0.44. If it's to the 10th value, then it will be 0.4. Here is another example. 12 over 15. Okay, we have 12 divided by the denominator 15. And we're seeing the same situation where 12 is not big enough to go into 15, so put 0. 120 divided by 15 is 8. And that just happens to do it. So 0.8 is the answer. What about this example? 21 over 12. 21 divided by 12. 1 goes into it. 21 minus 12 equals 9. And we need to place the decimal point here and bring it down. Now 90 divided by 12 is, we can use 7, and that comes out to 84. Then there's 6 here, bring down the 0. Then we get 5. So the answer for this is 1.75. Now here's another example that would result in repeated decimal points. 3 over 9. 3 divided by 9. 3 is not big enough for 9, so 0.30 divided by 9, we get 3. And then 27, and 3 again. 3, 27, and you can see that this will keep repeating. Our answer could just be simply put as 0.3 with the overbar on top. The overbar on top means that it's repeated decimal point, means that this number 3 will continue on infinitely. So this could be 0.3333333, and so forth. Now let's do one with a bigger number. 27 divided by 112. Okay, so we're starting with 27, the numerator, divided by 112, the denominator. The 27 is not big enough for the 112, so we'll put a 0, and then we'll add a 0 here. 270 divided by 112. 2 can go into it. 224 becomes 46. 4, bring down the 0. It's 4. 448. 12. Bring down the 0. And this will be 1. 112. 8. 80. 0. And then we'll bring down another 0 because 80 is not big enough to divide by 112. So with 800 divided by 112, we will have 7. 784. And that comes out to 16. We can tell that it's going to be a very long decimal answer. So if it was mentioned to you that you need to convert it to the hundredths value, then we will have 0.24 as the answer. And if they wanted to convert to the thousands, then it would be 0.241. And if you wanted to go even further, it could be 0.2411, and so on. In this video, I'll be going over how to convert fractions to percent. The two steps that you need to follow is number 1, numerator divided by the denominator, and then after that, multiply by 100. Here is an example. 3/8. So we're gonna do the first step, which is numerator divided by the denominator. So we're taking 3 divided by 8. So we can see that 3 is smaller than 8, so this will create a decimal here, and then 0 on top, a decimal point, and it will place a 0 behind it. Now we're going to take 30 divided by 8, and we can times 8 by 3, and that 8 times 3 equals 24. Okay, so we bring the 6 down, and then another 0, we bring that down. Now we have 60 divided by 8, and we can put 7 here, so 7 times 8, 56, and 60 minus 56 is 4. Then we bring down another 0, and we all know 8 times 5 is 40. Now I don't have any room here, but that will become 0 as a remainder. So our answer here is 0.375. And then the next step will be multiplying by 100. And the reason why we're multiplying by 100 because percent is per 100. So we're timesing this number by 100. And when you times by 100, you're basically moving 2 decimal to the right, and that gave us 37.5%. And that is the answer. Now what about this question? 2/25. Now let's try this again. Now let's go through the same process again. Numerator divided by denominator. So we're gonna take the 2 divided by 25. And here we can see 2 is too small for 25. So we're gonna put a decimal point here, put a 0 behind it, and do the same on top because no number can go into 25. 25 times 0 will give it, and we'll place a 0 with a decimal point here, like so. And now we have 20 divided by 25, and it's still too small, so we'll place another 0 on top, and then another 0 as a placeholder. Now we have 200 divided by 25. And we can put 8 because 8 times 25 is 200. So that equals 0. And that's our answer at 0.08. And then we'll do the second step, which is multiplying by 100. And then again, we're moving 2 decimal point to the right, and that will give us 8% as the answer. So this means that 2 over 25 equals 8%. What about this one? 5 over 12. Taking the numerator divided by the denominator, we have 5 divided by 12. And then we can see 5 is too small for 12. So we're placing a decimal and a 0 behind and doing the same on the top with a decimal point. And now that we have 50 divided by 12, we can see that 4 goes into it. So 4 times 12 is 48. And after we minus 50 to 48, we get 2. And next, we're gonna bring the 0 down here. So now we're taking 20 divided by 12. And we can see that 1 will go into it. And then 20 minus 12 is 8. Then we're gonna go ahead and bring another 0 down because the remainder is 8. So we'll have 80 divided by 12. And you can see that 6 will go into it, and this will become 72. And then you'll see 8 again. Then we have to bring down the 0. And we can see that this is going to repeat because it will continue to become 80 as the remainder. And as we keep putting 6 as the answer, and as we keep putting 6 on top, it will continue to be 72. So this will keep going 6, 6, 6, 6. So we know this is a repeat decimal. So this would be equivalent to 0.416 with a bar on top. And the bar on top means that it's a repeat decimal. 6 with a bar on top, and that means that it's a repeat decimal. Now if we take 0.416 times by 100, we'll get. Now we'll do the second step, which we're taking 0.416 times by 100, and we're moving 2 decimal point, which becomes 41.6%. And that is our answer. What about this one? 7 over 36. Now feel free to pause the video if you need time to figure this out yourself before the answer is revealed. So we're gonna start the process the same way with step number 1, which is numerator divided by denominator. So in this case, 7 divided by 36. Now the 7 is too small for 36, so this will be 0, and then we're gonna place a decimal point and then place a 0 behind it. So now this becomes 70 divided by 36, and 1 can go into that, and we can come up with 34 here. So we need to bring down another 0. Now 340 divided by 36, 9 can go into it, and that comes out to 324. Now 340 minus 324 is 16. And we need to bring down another 0. And what is 160 divided by 36? 4 can go into that. And that comes out to 144. 160 minus 144 is 16. And then we're going to bring another 0 down. Now we start seeing a pattern of 16 being the denominator every time we place a 4 on top. So we know that the 4 is going to repeat. Therefore, the answer will be written as 0.194 with a bar on top, meaning that this is a repeat decimal. And next, we're going to multiply by 100. So 0.194 times by 100, we'll be moving the decimal 2 points to the right, which gives us 19.4%. And that is our answer. So these 4 examples are how you will convert fractions to percent. In this video, I'll be going over how to simplify fractions. There are 3 steps when it comes to simplifying fractions. First step is to have a factor list for both numerator and the denominator. Secondly, find the greatest common factor. And lastly, divide by the greatest common factor. Here is an example, 10 over 14. So the first step is to find the factor list. So we'll take 10 and 14, and then we'll find a sequence of numbers which can multiply into 10. So for 10, we can see 1 times 10 is 10, 2 times 5 is 10, and then 3 doesn't work, 4 doesn't work, 5 times 2 is 10, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 doesn't work, and finally 10. For 14, we have 1 times 14 is 14, and then 2 times 7 is 14, and 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 times 2 is 14, 8 doesn't work, 9 doesn't work, 10 doesn't work, 11 doesn't work, 12 doesn't work, 13 doesn't work, and then we have 14. So the next step would then be to find the greatest common factor from the factor list. So the biggest number that we can find from both numbers is 2. So therefore, when we are simplifying this fraction, we are dividing it by the greatest common factor, both the numerator and the denominator. So since we found 2 was the greatest common factor, so we're dividing the 10 by 2, and we're dividing the 14 by 2. And then 10 divided by 2, we have 5, and then 14 divided by 2 is 7. And how do we know when we can no longer simplify anymore? Whenever you reach to a point where the greatest common factor is 1, that's when you know you can no longer simplify further. So in this case, since we are at 5 over 7, we could look at 5 and 7. You can see 1 times 5 is 5. 2 doesn't work, 3 doesn't work, 4 doesn't work, then we have 5. For 7, we have 1, so 1 times 7, and then 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, then we have 7. So in this case, the greatest common factor was 1, and that's how you know this is the final answer. Now what about this one? To find the factor list, We're going to do it again. So placing 9 and 27 on the bottom and trying to find the greatest common factor. So 9, we have 1 times 9, and then 3 times 3 is 9. The next one will be 9. So that's all we have for 9. For 27, again, we have 1 times 27, and then we have 3 times 9 is 27, and then we have 9 times 3 is 27. And then the last one will be 27 times 1 is 27. So the greatest common factor here is 9. So we'll divide the numerator and the denominator by 9 here, and we'll see that this resulted in 1 over 3. And to check on the answer, making sure that we've done everything correctly, we'll look at 1 and 3. 1 can only be 1. 3, 1 times 3 is 3, and then we have 3. We see the common denominator being 1, so we know the answer. So we know this is the answer. Here's another question. 20 over 60. We're going to go through the same process. First, finding the factor list. Okay, so we can see 1 will work, 2 will work, 4 times 5 is 20, 5 times 4 is 20, 10 times 2 is 20, and then 20 times 1 is 20. For 60, 1, 2 times 30 is 60, 4 times 15 is 60, 5 times 12 is 60, 10 times 6 is 60, 12 times 5 is 60, 15 times 4 is 60, 20 times 3 is 60, 30 times 2 is 60, and then we have 60. So from here, we're going to find the greatest common factor. For 20, this is the greatest common factor for both numbers. So we're going to go ahead and divide both numerator and the denominator by 20. And we'll get 1 over 3. And lastly, again, just making sure this is, you can no longer further simplify. We're taking 1, so we know there's only 1, and 3 is 1 and 3. So only 1 can go into it, which means 1/3 is our answer. Now there is also another way that you can do this question. Especially when you have larger numbers, is that you could, as long as you can think of a number where both the numerator and denominator can divide into, you could simplify multiple times. So for example, 20 and 60, we know that they're both even numbers, so we can definitely divide both by 2. And we'll see that the numerator will become 10 and the denominator will become 30. And then we look at the number again, they're still both even numbers, so let's divide by 2 again. Now that will become 5, and the denominator will be 15. Now that we see 5 and 15, we know both can go into 5, so we'll divide 5 for both, and answer is 1/3. Now can it divide any further? We can see the only way you can do it is by 1. And so therefore, this would be the answer. Here's another question. 14 divided by 49. We're finding the factor list. 1, 2, and 7. For 49, 1, 7, and 49. Greatest common factor, 7. Dividing by 7, 2 and 7. And then, final check, 1 and 2, 1 and 7. So that's the answer. So these 4 are examples of how you would simplify fractions. In this video, I'll be going over how to convert improper fractions to mixed numbers. The 4 steps for conversion is 1. Divide. Secondly, using the answer as the whole number. Number 3, place the remainder as the numerator. And number 4, the divisor as the denominator. Here is an example. 21 over 4. So the first step that we would do is to divide. So we would take 21 divided by 4. Then we would times that by 5 to get to 20. 21 minus 20 is 1. Now, how do we convert this to a mixed number? The answer that we got, 5, this would be the whole number. So we will place it like so. The remainder here would be the numerator. And the divisor, 4, would be the denominator. So this would be our answer for the mixed number. Now what about this one? To go through the same process, we want to first divide. And we would times 9 by 3 to get 27. Subtract. 31 minus 27 is 4. Again, we want to go ahead and convert that to a mixed number. So the whole number here would be 3. The remainder, we want to place right on as a numerator, 4. And then the divisor of 9, that would be our denominator. So our answer would be 3, 4 over 9. Here is another problem. 48 over 8. Using the same method, 48 divided by 8. And this one should be easy. We know it's going to be 6 because 6 times 8 is 48. 48 minus 48 is 0. So in this scenario, where the remainder is 0, then our answer would just be a whole number, which is 6. Because if we were to place the 0 as the numerator, and then we placed the number 8 as the denominator, 0 over 8 would have been 0. So therefore, this wouldn't be necessary. And the answer would be 6. Here's the next problem. 65 over 7. Going through the division process. We can see 7 times 9 equals 63. 65 minus 63 is 2. In this case, we have 9 as the whole number. Remainder is 2. And the divisor is 7. And this is the answer. So these 4 are examples of how you would convert improper fractions to mixed numbers. In this video, I'll be going over how to multiply whole numbers and fractions. The 3 steps to doing this is to first convert a whole number to fraction, next multiply, and then lastly simplify if any. Here is an example. 5 times 1 over 3. In this case, we can see the 5 is a whole number. So we need to convert the 5 to fraction before we multiply them together. So 5 will be converted to 5 over 1 times 1 over 3. So the next part that we wanted to do was to handle the multiplication. So what we would do is we would times 5 to 1 and 1 to 3, and that will give us 5 and 3. Next, we will try to simplify if we could. In this case, we have 5 and 3, so this is actually the final answer here. However, it is an improper fraction because the numerator is bigger than the denominator. And in this case, to convert this to a mixed number, we would take the 5 divided by the 3. Here will be 1, 3 times 1 is 3, 2. And from here, you can see 1 is the whole number. 2, the remainder will become the numerator here. And the divisor would be the denominator here. So answer is 1 and 2/3. We also have a video on mixed number conversion to fraction. And that will be also provided in the comment section of this video. So feel free to check it out if you need further assistance in converting improper fractions to mixed numbers. Here is another one. 9 times 2 over 7. So we're going to go ahead and convert a whole number to fraction. Then we're going to multiply. (18 over 7). Okay, and lastly, we're going to simplify. Again, this is also an improper fraction, as 18 is greater than 7. So we'll take 18 divided by 7. This is 2. 14. 18 minus 4 is 4. So then we have 2 as a whole. Numerator is 4 from the remainder, and 7 from the divisor. And 2 and 4, 7 will be your answer. And here's the next one. This time the fraction is in front of the whole number. However, the process remains the same. What we want to do is convert a whole number to a fraction. And then we're going to multiply. Okay, lastly, simplify. This one's an improper fraction, the numerator being bigger than denominator. So again, we're going to take 14 divided by 5. You can see this will be 2. 14 minus 10 is 4. So 2 will be the whole number. The numerator is 4. Denominator is 5. 2 and 4/5 is the answer. Here's the next problem. Okay, converting whole number to fraction. Multiply. Simplify. Improper fraction, 28 over 7. 4. 7 times 4 is 28. We get a remainder of 0. So the answer will be 4. There is also another way to handling this. When we get to this point here, we can see that the numerator and the denominator here are the same. So we could actually simplify before we multiply. In this case, 7 divided by 7 and 7 divided by 7. And that would give us 1 for each. So we can cross them out and replace the 7 for 1. Next, we would just take the 4. 4 times by the 1 equals 4. 1 times 1 is 1. And we can see that the answer also comes out to be 4. So a good practice is to simplify before you multiply. So these 4 are examples of how you will multiply whole numbers and fractions. In this video, I'll be going over how to add 3 fractions. The steps to adding 3 fractions. 1, we need to first find the common denominators. 2, we need to rewrite the fractions. 3, add them together. 4, simplify if needed. Adding 3 fractions is very much like adding 2 fractions, but in this case, there's 3 unlike denominators. So what we're going to do is find the common denominator first. In order to do that, we need to list out the multiples, and then we're going to have to find the least common multiple. So for 4, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. For 8, we will have 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. For 12, we have 12, 24, 36, 48, 60. To find the least common multiple, we need to locate the ones that all 3 numbers have in common. So, looking at these sets of numbers, we can see that 24 is the least common multiple for all 3 numbers. So our next step, now that we found the common denominator, is to multiply the denominator series. So they are all 24 in the denominator. So the first one, 4, we need to times by 6 to get to 24, and need to do the same in the numerator. The next fraction, 8, need to times by 3 to get to 24, and the numerator need to times by 3 as well. And for 12, we times by 2, and the 5 needs to times by 2 as well. Next, we're going to rewrite them. So 1 times 6 is 6. 4 times 6 is 24, plus 3 times 3 is 9. 8 times 3, 24. 5 times 2 is 10. 12 times 2 is 24. Now we have the denominators the same. All we gotta do is add the numerators together. So if we take 6 plus 9 plus 10, we would get 25, and the denominator would remain the same. So 25 over 24. Now we could still simplify them because 25 over 24 is an improper fraction, and we could take out 24 from here, so it would become 1 and 1 over 24. And that's our final answer. Now let's try another one. From this example, we have 3 unlike denominators. And again, we're going to find out the least common multiple for each. For 9, we have 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45. For 5, we have 5, 10, 15, 20, 25, 30, 35, 40, 45. For 15, we have 15, 30, 45, 60. And let's see if we can find the least common multiples in here. So going through all the numbers, we could see that 45 is the least common multiple for the 3 numbers. And so we're going to do that again. Multiply the denominators so that multiply the denominators so they are all the same. For 9, we need to times by 5. And the numerator by 5. For 5, we need to times by 9. The numerator as well. For 15, we need to times by 3. And the numerator by 3. Now to rewrite. So we have 4 times 5 is 20. 1 times 9 is 9. 3 times 3 is 9. Okay. Next, add them together. So 20 plus 9 plus 9. And we will have 38 over 45. Last part, see if we can simplify. And looking at this fraction, we couldn't simplify further. So this is the final answer. So these two are examples of how you would add 3 fractions with unlike denominators. In this video, I'll be going over how to compare fractions. In these examples, we can see that the denominators are different. So before we can compare them, we need to have a common denominator. So for the first example, we have 7 and 14. And we could list out the multiples for each to find the least common multiple. For 7, we take 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21. For 14, we have 14, and then 14 times 2 is 28. You can see 14 is the least common multiple for both numbers. So what we want to do is to get the denominator to be 14 for both fractions. For 7 to get to 14, we would times by 2. For 14, we would just simply times by 1. And when we multiply a number in the denominator, we need to do the same in the numerator. So 5 we need to times by 2 as well, and 12 need to times by 1. Then we will simply rewrite the fraction. 5 times 2 is 10, 7 times 2 is 14, and the other one, 12 times 1 is 12, and 14 times 1 is 14. Now that the denominators are the same, we can now compare the numerator, and 12 is bigger than 10, so it will look something like this. 12 over 14 is greater than 10 over 14. So the final answer is like so. Now for the second example, 3 over 10 and 2 over 16. So what we want to go ahead and list out the multiples. 10 will be 10, 20, 30, 40. For 6 would be 6, 12, 18, 24, 30, 36, 42. By looking at the two numbers, we can see 30 would be the least common multiple. To make both fractions with denominators of 30, 10 we need to times by 3. 6 we need to times by 5. And do the same in the numerator. And rewrite this, become 9 over 30, 10 over 30. So this one's close. 10 is greater than 9, so it will go this way. And the final answer would be 10 over 30 is greater than 9 over 30. So, which means 2 over 6 is greater than 3 over 10. What about this one? 5 over 6 and 7 over 8. Let's list out the multiples. 6 be 6, 12, 18, 24, 30, for 8, 8, 16, 24, 32. The least common multiple that both numbers share is 24. And for 6, we'll need to times by 4 to reach 24. For 8, we'll need to times by 3 to reach 24. And do the same in the numerator. Then we'll rewrite this. 5 times 4 is 20, 24, and then 7 times 3 is 21 over 24. 21 is greater than 20, so it will be 21 over 24 is greater than 20 over 24, which means 7 over 8 is greater than 5 over 6. Now the next one. 5 over 12 and 9 over 24. Now listing out the multiples. 12 be 12, 24, 36, and 24 be 24, 48. And we could see 24 would be the least common multiple. So we'll times 12 by 2 and 24 by 1. 5 times 2 is 10. Then this is 24, 9, and then 24. So in this case, 10 over 24 is greater than 9 over 24, which means 5 over 12 is greater than 9 over 24. So these 4 are examples of how you would compare fractions by finding out the common denominator. In this video, I'll be going over equivalent fractions. Equivalent fractions are fractions that may have different numbers but have the same value. And you could get to the equivalent fraction by either multiplication or division. And because of that, the equivalent fraction could be unlimited numbers of. Here is an example. 1 over 4. What would the equivalent fraction be? To get the equivalent fraction, you would need to multiply the denominator and the numerator by the same number, or divide the denominator and the numerator by the same number. In this case, 1 over 4, if we want to times by 2, and the same in the numerator, the result that we would have would be 2 over 8. So this is the equivalent value to 1 over 4. Now what if I wanted to multiply by 5? Then we would have 5 over 20. And that is the equivalent fraction of 1 over 4. What about 100? If we multiply 1 by 100 and 4 by 100, we would have 100 over 400. And that is also an equivalent fraction of 1 over 4. So as you can see, there would be unlimited number of equivalent fraction because you would be able to multiply by whatever number that you wish to and still be equivalent to 1 over 4. So even if we were to go more extreme, 1 times by, say, 10,000, and 4 times by 10,000, we will have 10,000 over 40,000. And that is an equivalent fraction to 1 over 4. Now let's try a different one. 15 over 60. With this fraction, we could multiply or we could divide, because both numbers could be divisible by a certain number. In this case, 15 could be divisible by 5, same for 60, and we will have 3 over 12. And that is equivalent to 15 over 60. You will be able to also divide by a different number if you wish. For example, you can also divide by 3. 15 divided by 3 is 5. 60 divided by 3 is 20. So 5 over 20 is also equivalent to 15 over 60. Or you could even divide by 15. That would come out to 1 and 4. Or maybe you want to multiply, say by 2. You would have 30 and 120. So everything here are equivalent to 15 over 60. So there's an unlimited number of possibility when it comes to equivalent fractions. Now, what if you have something like this, where it's giving you a certain value of the denominator and asks you to provide the numerator value? For something like this, there would be only one answer because the denominator has already been determined to be 15. So to solve this, we would find out 5 need to times by 3 to reach 15. So 4 would need to times by 3 as well. And so 4 times 3 equals 12. So 12 over 15 would be the answer. Now what about this one? It's asking for the denominator value and giving you the numerator value. So 12 over 30 equals 6 over what number? So an example like this, we will find out the numerator is divisible by 2 to reach 6. So we need to do the same in the denominator. 30 divided by 2, and the answer is 15. So these 4 are examples of how you will find equivalent fractions, either by unlimited combinations of values or a predetermined value asking you to find either the numerator or the denominator of that fraction. In this video, I'll be going over how to convert percent to fractions. The first thing to keep in mind is that percent means per 100. So the first example that we have here, 75%, is equivalent to 75 over 100. Now that we have it converted to fraction, and the greatest common factor between 75 and 100, for 75 we have 1, 5, and 25. For 100, we have 1, 5, and 25. So the greatest common factor in this case would be 25. So that means we could divide the numerator and the denominator by 25, and that will give us 3 over 4. So the answer in this case of 75% is 2 fraction of 3 over 4. Now what about this one? 40%. So 40 per 100 is 40 over 100. Now let's try to simplify that. So the 40 and 100's greatest common factor are 40 would be 1, 2, 4, 5, 8, 10, 20. And for 100, we have 1, 2, 4, 5, 10, 20. So the greatest common factor in this case is 20. So that means that we could divide by 20, and that will give us 2 over 5. So that means 40% is equivalent to 2 over 5. Now here is another one, 8%. So 8 out of 100, and we have common denominators of 8 and 100. For 8, we have 1, 2, 4, and 8. For 100, we have 1, 2, 4, 5, 10, 20, and so forth. And from here, we can see the greatest common factor is 4. So we can divide both by 4, and that gives us 2 over 25. And therefore, 8% is equivalent to 2 over 25. And here is our final example, 125%. Now this one is above the 100%, but it still works the same way. So 125% means that it's 125 out of 100. So 125. So 125 over 100. Now since this is an improper fraction, we can first convert it to a mixed number. So from here, we could definitely take out 100. So that would make it 1. And the remaining would be 25 over 100. And after that, we could simplify just the fraction portion of the mixed number. And so now we would find the greatest common factor between 25 and 100. So for 25, have 1, 5, 25. 100, I have 1, 5, 10, 20, 25. And here we can see 25 is the greatest common factor. So we can divide 25 here and 25 here. And that gives us 1 and 1/4. And therefore, 125% is equivalent to 1 and 1/4. So these four are examples of how you would convert percent to fractions. In this video, I'll be going over how to convert mixed numbers to improper fractions. Here is an example, 5 and 3/4. To convert mixed number to improper fraction, we would take the whole number times the denominator and then add the numerator. And that will be our new numerator. So 5 times 4 is 20, plus 3 is 23. So we have 23 over 4. And that's the improper fraction. Now we can check. Now if we want to check if we did this correctly, all we have to do is to divide the numerator by the denominator and see if the answer come out to 5 and 3/4. So we can go ahead and take 23 divided by 4, and here we'll have 5, 20, so 23 minus 20 is 3. So the improper fraction then, so the mixed number would be 5 and 3/4. And that's the same as the original question. This tells us that the improper fraction that we got of 23 over 4 is correct. Now let's try another one. Using the same step, we will take 4 times 9 and then add the 7. 4 times 9, 36, plus 7, 43. So we will have 43 over 9 as the improper fraction. To check if we did this correct, 43 divided by 9, 4, 36. 43 minus 36, we can have 7. That's the remainder. So the mixed number would be 4 and 7/9. And this matches the original problem, which tells us that the improper fraction that we got is correct. Now here's another example. So we're going to take 9 times 5 plus 3. So 9 times 5 is 45 plus 3 equals 48. So the improper fraction would be 48 over 5. Now to double check this, 48 divided by 5, we will have 9. 3 as a remainder. So the whole number is 9. The remainder is the numerator. Divisor is the denominator. So this number, 9 and 3/5, matches the original problem. And this tells us that we did the improper fraction correctly. Here's a final example. So we're going to take 6 times 2. Then we're going to add the 1. So we have total is 13. So the answer is 13 over 2. Again, we're going to check the answer. So we take 13 divided by 2. 6. 13 minus 12 is 1. That's the remainder. So the mixed number will be 6 and 1/2. Number matches the original problem, which tells us that the improper fraction that we calculated is correct. So these four are examples of how you would convert mixed number to improper fractions. In this video, I'll be going over how to divide fractions by whole numbers. In order to divide fractions by whole numbers, we need to first change the division to multiplication. and then we'll flip the divisor. In our first example of 1/2 divided by 5, the first part is to switch the division to multiplication. So change that to multiplication. And then we will flip the divisor here of 5. So 5 would be 5 over 1. To flip it, it would become 1 over 5. Then we can multiply. And after multiplication, we get 1 over 10. And that will be the answer. What about the next one here? 3 over 4 divided by 9. Using the same process, let's change division to multiplication. And let's flip the divisor. So 9 over 1 here will flip and become 1 over 9. Now before we multiply, we could simplify this, because I can see that the 3 and 9 are both divisible by 3. So this can be turned into 1 after you divide by 3, and this will become 3. And now we can multiply. So 1 times 1 is 1, and 4 times 3 is 12. And therefore the answer is 1 over 12. Now let's try this one. 5 over 9 divided by 6. Changing the operator to multiplication. Now for the divisor, we're going to convert it to fraction, then flip them, and that becomes 1 over 6. And for this one, we can simplify before multiplication. So 5 times 1 is 5. 9 times 6 is 54. And that is the answer. Now for our last example, have 7 over 8 divided by 4. So for this example here, I'm gonna go ahead and then have the division change to multiplication. Now we gotta flip the divisor. And for this one, we also cannot simplify before we multiply. So we're gonna go ahead and multiply here. 7 times 1 is 7. 8 times 4 is 32. So the final answer here is 7 over 32. So these 4 examples here are how you would divide fractions by whole number. In this video, I'll be going over how to find fraction of a number. From this example, the word of means multiplication. So we could simply rewrite this as 1/3 times 5. When you're multiplying a fraction to a whole number, you want to first convert the whole number to a fraction. So we will rewrite this as 1/3 times 5 over 1. Then we will simply multiply across, and that will become 5 over 3. Now we can see this is an improper fraction. So we're gonna convert it to a mixed number. To convert it to a mixed number, we can just divide the numerator by the denominator. 5 divided by 3 is 1. 5 minus 3 is 2. So we have 2 as a remainder. And the mixed number would be 1, 2 over 3. What about this one? Using the same process, changing of to multiplication, 2 over 7 times by 10 over 1, multiply across, 20 over 7. Final step, convert the improper fraction to mixed number. Have 2. 20 minus 14 is 6. 6 is remainder. So we'll have the mixed number as 2, 6 over 7. Now what about this one? Using the same process, changing of to multiply 4 over 9 times 81 over 1. Now by looking at this, we can see that we could simplify before we multiply. So here, 81 and 9 are both divisible by 9. And therefore this becomes 9 and this becomes 1. If we rewrite this, it would be 4 over 1 times 9 over 1. And 4 times 9 is 36 over 1, which is 36. Now what about this one? Changing of to multiplication. 5 over 12 times 36 over 1. 36 and 12 could be simplified before we multiply. They are both divisible by 12. This becomes 3 and this becomes 1. If we rewrite this, 5 times 3 is 15. And our answer is 15. So these 4 examples are how you would calculate fraction of a number. In this video, I'll be going over how to order fractions with unlike denominators. To place fractions in order, we need to make sure that they have this common denominator. Otherwise, we can't compare which one's greater than the other. So we have 2 examples underneath, and we're going to place them in order from lowest to the greatest. For the first example, we can see there's different denominators, and we need to find the least common multiple. So what we're going to do is we're going to put 2, and then we have 4, and then we have 8. And then we're going to list out the multiples. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3, 6. 2 times 4 is 8. 2 times 5 is 10. For 4, we have 4 times 1 is 4. 8, 12, 16, 20. For 8, we have 8, 16, 24, 32. So we're going to find the least common multiple. In this example, we're looking for the lowest number that they have in common. So after going through the numbers, the least common multiple that we can find would be 8. Now that we know the value is 8, what we need to do is convert each of them with so that they have the common denominator of 8. So for 3/2, if we were to convert to 8, that means the denominator needs to times by 4 and the numerator needs to times by 4. And we get 3 times 4 is 12. So 3/2 is equivalent to 12/8. So we'll write 12/8 underneath 3/2. Now the second number that we have is 5/8. And 5/8 already has a denominator of 8, so we'll leave that as it is. Next, we have 1/4 And 1/4 converting to 8 require denominator to times by 2 and the numerator times by 2. And we have 2/8. And so we'll write 2/8 underneath. And the last one, 3/8, is also with the 8 as a denominator, so we don't need to do anything there. And now that we have everything with the common denominator, we can now list them from least to the greatest. Here, 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 and here. 2/8 would be the lowest. And 2/8 is equivalent to 1/4, so we're going to write 1/4 first. Second one is 3/8. And then the third will be 5/8. And lastly, 12/8. And 12/8 is actually 3/2, so we're going to write 3/2. And so the answer will, from least to greatest, will look like this. Now let's move on to example number 2. And again, we're going to find the least common multiple. And the denominators are 9, 18, and 6. So we'll go 6, and then 9, and 18. Since we have 2 9s, we only need to find the least common multiple for 1. So 6 would be 6 times 1 is 6, and 12, 18, 24. For 9 would be 9, 18, 27, 36. 18 would be 18, 36. And just by looking at these numbers, looking for the common denominator, we can see that 18 would be the least common multiple. So now we're going to convert everything to fraction with denominator of 18. So for the first one, 2/9, converting to 18 as denominator, we need to times that by 2 and the numerator by 2. And our answer is 4/18. So we'll mark as 4/18 underneath. The next one, 6/18, is already with the 18 as denominator, so we'll do nothing there. The third number, 1/6, we need to times by 3 to get to 18, and then the numerator by 3 as well. So then we have 3/18. And lastly, we have 4/9, and we're going to need to times that by 2. Then we have 8 and 18. So now we're going to go ahead and do the comparison between the 4 fractions. And the 4 are here, 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 and here. The smallest number will be 3/18, which is 1/6. So we're going to put 1/6. Next would be 4/18, which is 2/9. And the third would be 6/18. And last would be 8/18, which is 4/9. And this would be the final answer. So these two are examples of how you would order fractions with unlike denominators. In this video, I'll be going over how to add fractions with this shortcut math trick. Let's first place our attention to the center of the formula. What we want to do is we want to first multiply the denominators. And the second step, we will be cross-multiplying the numerators. Let's go through some examples and see how this works. First one, 2/5 plus 1/3. So first, we will multiply the denominators. And that will be 5 times 3, 15. And then we will take 1 times 5, 2 times 3. So 2 times 3 is 6. 1 times 5 is 5. So we add them together. And that gives us 11/15. And that's the answer for example 1. In a traditional way, we used to find the least common multiples for the denominators. With this way, we're not doing that. Instead, we're multiplying the denominators together. But if the answer does come out where we need to simplify further, then we will simplify after. This is a good way to add fractions fast and get answer right away. So let's look at example 2. We have 1/7 plus 3/4. So 7 times 4, 28. 1 times 4 is 4. 7 times 3, 21. 25/28 is the answer. Now, since we can simplify further, that would be the answer for example 2. Now, let's move on to example 3. 2/3 plus 1/4. 3 times 4 is 12. 2 times 4 is 8. 3 times 1 is 3. So we have 11/12. And this also does not require simplification, so that will be the final answer. Now moving on to fourth example, we have 5/6 plus 1/2. 6 times 2, 12. 5 times 2, 10. 6 times 1, 6. Now we have 16/12. Now 16/12 we can simplify further. So if we divide this by 4, we will have 4/3. So this is an example where we do need to simplify afterwards. Now for example 5, 8 times 3, 24. 3 times 3 is 9. 8 times 1 is 8. So we have 17/24. So these are 5 examples of how you would add fraction using the shortcut trick. It bypasses finding out the least common multiples, and you can find the answer faster, but may need simplification afterwards. In this video, I'll be going over how to subtract fractions with this shortcut trick. Let's first pay attention to the formula in the center of the screen. So what we want to do is we want to multiply the denominators so they are the same. Then next, we will cross multiply the numerators and subtract them. In the original method, we would find the least common multiple, but in this shortcut trick, we're multiplying the denominators together and then simplify after. And then simplify if needed after. So let's look at the first example that we have. 6/9 minus 1/4. First step, we're going to multiply the denominator. 9 times 4, 36. And then we'll take 6 times 4, 24. Then we'll subtract by 9 times 1, which is 9. So 24 minus 9, and the answer is 15. So the answer is 15 over 36. Since we cannot simplify any further, that is the answer. Now let's look at example number 2. We have 5 6 minus 3 7. So 6 times 7, 42. 5 times 7, 35. Minus 6 times 3, 18. 35 minus 18 is 17. So we have 17 over 42. And since we cannot simplify anymore, 17 over 42 is the answer. For example 3, 3 times 5, 15. 2 times 5, 10. Minus 3 times 1, 3. 7 over 15. And we also couldn't simplify this any further, so that's the answer. And let's move on to example 4. 5 times 7, 35. 4 times 7, 28. 5 times 2, 10. This equals 18 over 35. And since we cannot simplify further, that would be the answer. So originally we used to find the least common multiple, and that normally takes some time. With this way, we're actually eliminating that. As you can see from the 4 examples that were provided, none of them require simplification. So it's a good practice to, if you want to find the answers of subtracting fractions in a fast manner, that we do it this way. And if we need to simplify further, then we can simplify after. But this allows us to find most of the answers quickly and without having to do extra work at first. In this video, I'll be going over how to find fractions on a number line. The first step is to divide the sections. Second step is to move the number of spaces based on the numerator. In our first example, we have 3/8. 3/8 would fall between 0 and 1. Below we have a number line with 0 and 1. And we need to place the point exactly where 3/8 is. So the first step is to divide the sections. Since we have the denominator as 8, so we are going to divide 8 sections. Starting from the middle, because since it's 8, we know there's going to be 8 sections. So the middle part would be 4/8. And then you would need 3 sections here. So this would be 1/8, 2/8, and 3/8. Then you would need 3 sections on the right half as well. So we would have 5, 6, 7. So 5/8, 6/8, 7/8, and 1 would be 8/8. So 3/8 would be right here. And here is where we want to place the dot. And that's number of spaces 3 for 1, 2, 3, like so. And we can see that it's 3/8 right here. Now for the second one, we have 1/3. So in order to divide the sections, we first look at the denominator of 3, and we know we need to divide 3 sections between 0 and 1. And so 3 sections, we can approximate that's going to look something like this. So that's total of 3 sections. You can see that's 1 section, 2 section, and 3 section. So the first section would be 1/3. Second section will be 2/3, and the last section will be 3/3. So therefore 1/3 will be here, and that is one space of numerator starting from 0. And so this is where you will want to plot the dot. Now for the third example, 3/5. So we know the denominator of 5 needs to divide the section into 5. So looking at between 0 and 1, so we could go 1, 2, 3, 4, and this is 5. So the first line would be 1/5, second line would be 2/5, and then 3/5, 4/5, and the 1 is 5/5. And so looking at the numerator, 3, we go 3 spaces, and that will be exactly 3/5 here, and that's where we will plot the dot. So the dividing of sections will get easier the more that you practice. And let's move on to the fourth example, where we have 4/6. So 4/6, we have 6 sections, which we're going to divide, and it will look something like this. 1, 2, 3, 4, 5. That's 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and finally the 1 is 6, 6. So the numerator 4, moving the 4 spaces, and that will land us exactly on 4/6, and that's where we will plot the dot. So these are 4 examples of how you would find fractions on a number line. You want to first divide the sections, then move the number of spaces based on the numerator. Or if you are writing each of the fraction out, you could simply locate where you need to plot the dot and plot the dot accordingly. In this video, I'll be going over how to multiply fractions using area model. The way that we would do this is we're going to separate both fractions, one horizontally and one vertically, depending on the denominator and the numerator, and then we'll find the answer by the overlapping squares. This all may seem confusing right now, but we'll go over the 2 examples below, and you will see how it works. So the first example, 3/5 times 2/3. So we'll first look at the first fraction, 3/5. The denominator is 5, which means that we're going to separate 5 sections horizontally. So that's 1, 2, 3, 4. And so you see there's a total of 5 sections that I just created. Then we're going to look at the numerator is 3. This means that we need to shade 3 out of the 5 sections that we've just created. Okay, so that's 3 out of 5. Next, I'm going to use a different color, and we see the denominator being 3, so that means we need to separate 3 sections, but this way we're going to do it vertically. So that's 1, 2. So now we have 3 sections, and we're going to shade 2 sections off of that. So let's shade here in yellow. Now lastly, all we have to do is look at the overlapping squares. And the overlapping would be 1, 2, 3, 4, 5, 6. So that tells us that we will have 6 out of total number of squares, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the answer is 6/15. Now 6 over 15 can be simplified by 3, so we could also divide this by 3, and so that would be 2 over 5, and that's our answer. Now the answer would come out the same if you were to take 3/5 times 2/3. The normal way would just take 5 times 3, which is 15, and 3 times 2 is 6. And then simplifying it would become 2/5. So the area model method is just another way that you can multiply fractions. Now let's look at the second example. 1/3 times 4/5. So first we look at the denominator, and we need to separate this into 3 sections. We need to shade one of them. We're going to look at the second fraction with 5. Divide this in 5 sections. The numerator of 4 means that we need to shade 4 of them. So we're going to shade the 4 sections out of the 5, which will be like so. And the area that overlap would be 1, 2, 3, and 4. So that tells us that we will have 4 as the numerator, and out of total number of boxes available, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the answer is 4 over 15. Now let's try to multiply and see if the answer comes out the same. If it's 1/3 times by 4/5, if we multiply 3 by 5, we get 15. Multiply 1 by 4 is 4. And you can see the answer would come out the same. So these two examples are how you would multiply fractions using area model. It's another method that you can multiply fractions. It may not be the most efficient method, but it is another way that you can find answers by drawing them out in boxes. In this video, I'll be going over how to divide whole number by fractions. The first step to doing so is to add 1 as the denominator. After you do that, it becomes fraction dividing by fraction. So you would change division to multiplication and then swap the numerator with the denominator of the second fraction. Now this may all seem confusing right now, but let's go over the 4 examples below, and I'm sure you will understand better after. So for the first example, we have 5 divided by 1/3. So we're going to do the first step, which is to add 1 as a denominator. Then we want to change division to multiplication. And lastly, we swap the second fraction, 1 and 3. So this will become 3 and 1. So if we were to rewrite this, we would have 5 over 1 times 3 over 1. And 5 times 3 is 15. 1 times 1 is 1. So we would have 15 as the answer. Now let's try the second example of 9 divided by 5 over 8. Adding the 1 in the denominator, change division to multiplication, swapping the second fraction, rewriting, Nine times 8 is 72 over 5. And we can simplify this as it's an improper fraction. So 14 and 2/5. That would be the answer. Now for the third example, using the same steps, denominator of 1, change to multiplication, swapping second fraction, rewriting. Now here we can see that 6 and 3 can all be divisible by 3, and that will be simplified. 2 as the numerator and a 1 as the denominator here. And so 2 times 4 is 8, and 1 times 1 is 1, so the answer would be 8. Now for the fourth example, adding 1 as the denominator, change it to multiplication, and swapping, rewriting. Now 12 times 8 is 96, and then 7 on the bottom. And it's an improper fraction. If we divide 96 by 7, we will have 1, 3, and 5 sevenths. So that would be 13 and 5 sevenths. So these 4 are examples of how you would divide whole numbers by fractions. In this video, I'll be going over how to subtract fractions from whole numbers. In order to subtract fractions from a whole number, we need to first make sure that they have the same common denominator. Then we will proceed with the subtraction. Below are 2 examples, and we'll be going over each one. For the first one, I have 8 minus 2 over 6. And we can see that both numbers, the first number we have is a whole number, and the second number is a fraction. So the first step is to convert the whole number to fraction. In order to do that, we need to have the same common denominator. So since the fraction we have here is 6, we need to convert 8 to a fraction with 6 as the denominator. So we're going to convert this with a 6 on the bottom, and the numerator needs to be a number where it will equal to 8. So if we have a denominator of 6, we would take 6, because 6 over 6 is 1. And we have 8 of them, so we need to multiply it by 8. And that would give us 48 over 6. And that would be the fraction for 8. And if you were to take 48 divided by 6, the answer would be 8. So now that we have the 8 converted to fraction, all we have to do is bring this fraction down 2 over 6. Now that they have the same common denominator, all we have to do is minus 48 to 2. And that becomes 46. So then this becomes 46 over 6. Now 46 over 6 is an improper fraction. So if you were to divide 46 by 6, we will have a whole number of 7 and then 4 over 6. 4 over 6 can be simplified to 2 over 3. That means the answer would be 7 and 2/3. Now there's also another way that you can do this. Since we have 8 as a whole number, we could take out 1 from 8 and make the whole number 7, and simply place 6 over 6 after 7. So this becomes a mixed number of 7 with 6 over 6, which is the same as 8. But this way will be faster because we're basically taking out the 1 and not having to convert it to an improper fraction and then back to a mixed number. So this way, we're basically converting from a whole number to a mixed number. And then we proceed with the subtraction. In this case, 7 will remain the same. Then we will take 6 over 6 minus by 2 over 6. And that will give us 4 over 6. And after simplifying it, we will get 7 and because the numerator and denominator can both divide by 2, so that gives us 2 over 3. And that is the same answer as the first method. But as you can see, this method is shorter and faster. Now let's try the second example. We have 10 minus 5/8. And for this one, I'm going to convert the whole number to a mixed number. So that would be 9. And since the second fraction that we are minusing to, it is with the denominator 8. So I'm going to put 8 over 8. Then we will minus 5 over 8. So simply taking 8 over 8 minus 5 over 8, we have 3 over 8. And the whole number would be 9 because 9 minus 0 is 9. And this gives us the mixed number of 9 and a 3/8 as the answer. So these two are examples of how you would subtract fractions from a whole number. You need to first make sure that you have the same common denominator and then subtract. And you can do so by converting the entire whole number to an improper fraction and then proceed with the subtraction. Or you can first convert the whole number to a mixed number, then proceed with the subtraction. Either way, the answer will come out the same. In this video, I'll be going over how to multiply 3 fractions. When we handle multiplication of 3 fractions, we want to first cancel or simplify before we do the multiplying. And the reason for that is because it will become a very big number if you just proceed and multiply the numbers together and then try to simplify it afterwards. So it's always a good idea to first either cancel or simplify before multiplying. For the first example, we have 8 over 14 times 2 over 5 times 5 over 8. And we can go ahead and write this out. And from here, we can see the 5 and 5 can cancel out. So they'll both becomes 1. And let's see if there's anything else. 8 and 8 also cancel out. Then we have 2 and 14. They can both divisible by 2. So 2 will become 1 and 14 will become 7. So now this becomes very easy. All you have to do is taking the 1 times 1 times 1 and then 7 times 1 times 1. And that will become 1 on top and then 7 at the bottom. So the answer is 1 over 7. Now if you don't do that ahead of time, what you will end up is taking 8 times 2 times 5 and then 14 times 5 times 8. And that will become a very big number, which you need to simplify afterwards to get to 1 over 7. Therefore, it's always recommended to cancel or simplify before multiplying. Now for the second example, we have 12 over 17 times 5 over 6 times 9 over 24. So we'll do the same thing. We'll look at all the numbers, see if we can cancel or simplify first. From here, you can see 12 and 24, they're both divisible by 12. So 12 become 1 and 24 become 2. And also see 9 and 6, both divisible by 3. 9 becomes 3, 6 becomes 2. And that looks like the only ones that are available. So we're going to take 1 times 5 times 3. Then we're going to take 17 times 2 times 2. So 1 times 5 times 3 is 15. And then we have 17 times 2 times 2. And that becomes 68. And so the answer is 15 over 68. So these are 2 examples of how you would multiply 3 fractions. In this video, I'll be going over fractions with exponents, also referred to as powers of fractions. When we're working with fractions with exponents, we want to first look at the exponent and then determine how many times we need to multiply that fraction. Below are 4 examples, we'll be going over each one. For the first example, we have 3 over 7 to the power of 3. So the first part we look at is the 3 here, the exponent. And since it's to the power of 3, we need to multiply 3 over 7 3 times. And if we multiply them together, 3 times 3 times 3, we will get 27. Then we have 7 times 7 times 7. Inputting that in the calculator, you would get 343. And that will be the answer for example 1. For the second example, we have 1/3 to the power of 4. So this time, we're going to multiply 1/3 4 times. So 1 times 1 times 1 times 1 is 1. And 3 times 3 times 3 times 3 would be 81. So the answer for this is 1 over 81. For the third example, we have 3/5 to the power of 5. So we'll take 3 over 5 and we're going to multiply that 5 times. Then we will multiply 3 by 3 by 3 by 3 by 3. From the calculator, that will become 243. Then we have 5 times 5 times 5 times 5 times 5. That equals 3,125. And that's the answer for number 3. And for our final example, we have 5 over 8 to the power of 2. So we're just multiplying twice. 5 over 8 multiplied by 5 over 8. So 5 times 5 is 25. And 8 times 8 is 64. And that will be the answer for example 4. So these 4 are examples of how you would solve fractions with exponents. In this video, I'll be going over what a reciprocal is. The steps to finding a reciprocal of a fraction or a number is to first you want to swap the numerator and the denominator. Then you can check if the answer is correct by multiplying by the reciprocal and see if the answer comes out to be 1. Below are 2 examples and we'll be going over each one. The first one is 5 over 7. So what we want to do is we want to swap the position, the numerator and the denominator, and that'll become 7 over 5. So 7 over 5 will be the reciprocal of 5 over 7. Now we can check the answer by taking 5 over 7 multiplied by 7 over 5, and the answer has to come out to 1 to be correct. So 5 over 7 times by 7 over 5, we can see that these will cross out and become 1. 5 and 5 will also cross out and become 1. So the answer is 1. And therefore, 7 over 5 will be the right answer. For the second example, we have a whole number of 8. And since this is not a fraction, we need to first convert it to a fraction. So 8 is equivalent to 8 over 1. Then we want to swap the numerator with the denominator and become 1 over 8. So 1 over 8 would be our answer for number 2. And we're going to go ahead and check the answer if it's done correctly. So we have 8 over 1 multiplied by 1 over 8. And we need to see if it becomes 1. So 8 and 8 are both divisible by 8, so that will equal to 1. And so 1 times 1 is 1, and 1 times 1 is 1. So therefore, the answer is 1. And that means 1 over 8 is the correct answer for example 2. So this is how you will find the reciprocal of a fraction. In this video, I'll be going over why do we invert and multiply. when we divide fractions. I've often been asked this question as to why do we invert and multiply when we divide fractions. So I've decided to make a video on this. As you can see from the example below, 5, 6 divided by 1/3. When we divide, we would flip the denominator and the numerator, and then we would change the sign of division to multiplication. So the final equation would become 5, 6 times by 3 over 1. So the question is, why do we do that? To answer this, we need to first go over some of the basic fundamentals of fraction. For example, 6 over 6 equals 1. Any of the same number in the numerator and denominator will equal to 1. So anything like, for example, 8 over 8 equals 1. 12 over 12 equals 1. So you get the picture. Now, the next part we need to understand is the reciprocal of a fraction. So, for example, if we have 5 over 6, what is the reciprocal of 5 over 6? The answer for that is 6 over 5. And when we multiply a fraction by its reciprocal, 5 over 6 multiplied by 6 over 5, the answer is always 1. Because 5 and 5 cross out and they become 1. 6 and 6 cross out becomes 1. So 1 times 1 is 1. 1 times 1 is 1. So eventually we get 1 over 1, which equals 1. And that's the reciprocal of a fraction. Anytime you multiply a reciprocal of a fraction, it will always become 1. Now to answer the question, why do we invert and multiply when we divide fractions? This is why. 5 over 6 divided by 1 over 3 is rewritten as 5 over 6 divided by 1 over 3. As we spoke about multiplying by its reciprocal equals 1, we are going to do the same here, where we're going to make the denominator into 1 by multiplying the denominator by its reciprocal. So the denominator is 1 over 3, so we're going to multiply that by 3 over 1. And that essentially will become 1 because they'll just cross multiply, and this will becomes 1. And now, whatever we do in the denominator, we need to do in the numerator. So we're multiplying the fraction of 5 over 6 by 3 over 1, like so. So now I think you can start seeing the picture. We have 5 over 6 times 3 over 1. Doesn't that look like what we have up here? So if you want to rewrite this, it will be 5 over 6 times 3 over 1 over 1. So anything over 1, any equation, any number over 1 is itself. So this would become 5 over 6 times 3 over 1. So that's why every time we divide a fraction, we end up just invert and multiply. But most of the teachers or educators, they don't really explain why. They just kind of tell you that's how you do it. And so this video explains why do we do it. In this video, I'll be going over how to multiply fractions using cancellation. The tip here is to simplify before multiplying. And below are 4 examples, I'll be going over each one. For the first example, we have 7 over 20 times 10 over 21. So the first thing we want to do is to look for numbers. We want to look for numbers either top and bottom, or diagonally, like so. So we can see 7 and 20 cannot both divide into anything, but 7 and 21 can both divide into 7. And so 7 divided by 7 is 1, and 21 divided by 7 is 3. Now what about 10 and 20? Both are divisible by 10. So 10 divided by 10 is 1, and 20 divided by 10 is 2. So now we are left with numbers that were circled. So next we'll take 1 times 1 equals 1. And then 2 times 3 equals 6. And that's our answer. Now if you don't simplify before multiplying, what you'll end up with would be something like this. 7 over 20 times by 10 over 21. 7 times 10 is 70. 20 times 21 will require a calculator, and it would come out to 420. And now you have to simplify these two big numbers. We can see that they are both divisible by 70. So 70 divided by 70 is 1, where 420 divided by 70 is 6. So you can see that both answers are the same. However, if we simplify before multiplying, what happens is you will result with the answer quicker instead of ending up with a bigger number which you have to simplify afterwards. Now let's take a look at example 2. We have 4 over 9 times by 27 over 12. Now let's look at the number up and down. 4 and 9 cannot both divide into a number. 27 and 12 also cannot both divide to a number. Now let's look at diagonally. 4 and 12 are both divisible by 4. So if we take 4 divided by 4, we will have 1. 12 divided by 4 is 3. Next, we have 27 and 9. And we can see 27 divided by 9 will become 3. And 9 divided by 9 will become 1. Now using the same process, we're going to go ahead and multiply the ones that I've circled after simplification. So 1 times 3 is 3. And 1 times 3 again is 3. And 3 over 3 is 1. So our final answer is 1. Now if we want to do it the original way, which we can also do, and also help us double check the work, is we take 4 over 9 times by 27 over 12. Without simplifying, 4 times 27 is 108. And 9 times 12, using a calculator, I see it's 108. So 108 over 108 is also 1. So therefore, the answers are both the same and correct. Now for the third example, we have 5 over 6. And in this example, we are multiplying by a whole number of 42. The method will remain the same, but first we want to do is to change the whole number to a fraction by converting 42 to 42 over 1, like so. And now we can go ahead and simplify as before. The first thing I notice is 42 and 6. They're both divisible by 6. And 6 divided by 6 is 1. 42 divided by 6 is 7. Okay, and 5 and 1, there's nothing there. So we'll go ahead and take the 5 times the 7 equals 35. And then we'll take the 1 multiplied by the 1 underneath, and that becomes 1. So then we will have the answer of 35. Now, if you want to try the long way without simplifying, okay, 5 times 42, multiplying on the calculator, we will get 210 over 6. 6 times 1. And if we take 210 divided by 6, we will get 35. And so the answer are both the same. For the last example, we have 3 over 4 times 2 and 4 is 6. So here we see that we are multiplying by a mixed number, 2 and 4 is 6. So the first step is to convert the mixed number to an improper fraction. So the way we would do that is we would first take the 2, multiply by the 6, and then we will add the 4. So 2 times 6 is 12, and 12 plus 4 is 16, so this will become 16 over 6. So we'll go ahead and rewrite this as 3 over 4 times 16 over 6, and we can see that 4 and 16 can both divisible by 4. So 16 divided by 4 will be 4. 4 divided by 4 will be 1. And 3 and 6, 3 divided by 3 is 6 divided by 3. 3 divided by 3 equals 1. 6 divided by 3 is 2. And taking the 1 times the 4 equals 4. Then we take the 1 times by 2, and we have 2. And 4 over 2 equals 2. So these are 4 examples of how you will multiply fractions using cancellation. In this video, I'll be going over adding fractions word problems. We are going to go over 2 word problems here with scenarios where we need to add different fractions together. The tip of the lesson is, whenever we combine fractions, we use addition. For the first example, Michael spent 1/5 of his time on studying and 1/3 of his time on playing video games. What fraction of his time has he spent? What fraction of his time is still remaining? In this scenario, we're combining fractions, so we're using addition. So we're going to take 1/5 of his time plus 1/3 of his time. Now we can see that we don't have a common denominator. So this is a scenario where we are adding fractions with unlike denominators. So we need to get them to have the same common denominators first. And to do that, we can multiply the denominator by the other denominator. So 1/5 we will multiply by 3. And if we multiply the denominator by 3, we need to multiply the numerator by 3 as well. And we'll do the same for 3. So 3 would then times by 5, and the numerator will also times by 5. Now if we rewrite this, 3 times 1 is 3, 3 times 5 is 15, and plus 1 times 5 is 5, 3 times 5 is 15, And now we have a common denominator of 15. So now we just need to add the 3 and 5 together and we get 8 over 15. And so 8 over 15 is the fraction of his time that he spent. Now what about the fraction of his time that's still remaining? Since we are going by fraction of his time, so the 100% of his time would be 15 over 15, which is 1 whole. And so if we take 15 over 15 minus 8 over 15, which is the time that he spent here, 15 minus 8 is 7 over 15. And so therefore, he still has 7 over 15 of his time remaining. Now for example 2, Sharon ate 1/4 of her cake yesterday and ate 1/5 of her cake today. What fraction of her cake did she eat? And what fraction of her cake is still remaining? So this is also a scenario where we are combining two fractions. So we're using addition here. Sharon ate 1/4 of her cake, and then she ate 1/5 of her cake. So it's another scenario we are adding fractions with unlike denominators. So we have 4 and 5. So we'll multiply 4 by 5. Same with the numerator. And for the denominator portion, 5 will need to times by 4, and numerator will also times by 4. And now we just need to rewrite them. So 5 times 1 is 5. 5 times 4 is 20. Plus 1 times 4 is 4. 5 times 4 is 20. So now we have common denominator of 20. So we just need to add the 5 and the 4. That gives us 9 over 20. And 9 over 20 is how much cake that Sharon ate altogether. And the second question asks, what fraction of her cake is still remaining? So 100% of her cake is 20 over 20. That's 1 whole. So we can take that 20 over 20 minus 9 over 20. And since the denominator are the same, we take 20 minus 9, and that becomes 11. So the cake that's still remaining is 11 over 20. So that's what's remaining. So these are two examples of adding fractions word problems. The tip here is that whenever we read these word problems, if we need to combine them together, we use addition to add the fractions together. And if you have unlike denominators, we need to get a common denominator and then add the numerator together to get the final answer. In this video, I'll be going over subtracting fraction word problems. Here are two word problems with scenarios where we need to subtract fractions. The tip for this lesson is, when taking something away or finding the difference, we subtract. So let's take a look at the first example. John had 3/4 of his allowance with him. He spent 1/6 of his allowance on candies. How much of his allowance does he have left? So in this scenario, we are starting with 3/4 of his allowance and taking away 1/6 of his allowance. When we are taking away something, we use subtraction. So we're going to take 3/4 minus 1/6. So we have a situation with subtraction of fraction with unlike denominator. We have 4 and 6, and we need them to have a common denominator. So we will multiply by each other in the denominator. 4 will multiply by 6, and numerator also by 6. When you multiply denominator by a certain number, you need to multiply the numerator also by the same number. And for the 6, we're gonna multiply by 4, and also the same for the numerator. And now we rewrite them. 6 times 3 is 18. 6 times 4, 24. Then we minus 1 times 4 is 4. 6 times 4 is 24. Now we have a common denominator. So we just need to subtract the numerator of 18 minus 4. So 18 minus 4 is 14 over 24. And we can see both numerator and denominator can divide by 2. So this will become 7 over 12 after we simplify. So 7 over 12 is how much of its allowance is still left. Now for the second example, Michelle ate 3/4 of an apple pie and Louis ate 3/5 of an apple pie. How much more did Michelle eat more than Louis? So in this scenario, it's a difference problem, as we need to find the difference between 3/4 and 3/5. And when we are finding the difference of fractions, we are subtracting. So we'll take 3/4 minus 3/5. Here we also have a situation with unlike denominator. So we'll do the same. The 4 will multiply by 5, and the 5 will multiply by 4. And do the same in the numerator as you did in the denominator. Now we rewrite 5 times 3 is 15. 5 times 4 is 20. Minus 3 times 4 is 12. 5 times 4 is 20. Now 15 minus 12, we have 3. And the common denominator is 20. So the answer is 3/20 more than Louis. So these two are examples of how you would subtract fraction word problems. The main point is when you are taking something away or finding the difference of fractions, we use subtraction. So the first example was taking something away, where John had 3/4 of his allowance and he spent 1/6 of his allowance. So he used 1/6 of his allowance from the 3/4 that he had originally. And the second example was a difference problem, comparing how much Michelle ate and how much Louis ate and finding the difference. In this video, I'll be going over multiplying fractions word problems. We are going over 3 word problems with scenarios when we need to multiply fractions. For the first example, 3/4 of the students want to play basketball. Of these students, 1/5 are girls. What fraction of the students are girls who want to play basketball? So what we have here is a fraction of a fraction problem. And whenever we see the word of in the word problem, we use multiplication. So what we are looking at is 3/4 of students who want to play basketball. So visually, we can see 3/4 of the students who want to play basketball. Of these students, 1/5 are girls. So from the 3/4 section, we're gonna divide into 5 equal groups. So that's 1, 2, 3, 4, 5. My drawings are not precise, but it gives you an idea of what we're talking about here. So what we want to know is from these 5 equal groups, 1/5 are girls. So here, the 1/5 are girls. And what we want to know is what fraction of all the students are girls who want to play basketball. Okay, so now at first we have 3/4 of a student, and we have 1/5 of a girl who wants to play basketball. So out of the 3/4, we are multiplying by 1/5 to find out what fraction this is. So this will be the setup that we're gonna use in this word problem. So 3/4 times by 1/5. So going back to the word problem, 3/4 times 1/5. And by multiplying across, we have 3 times 1 equals 3. And 4 times 5 equals 20. So our answer is 3/20 of the students who are girls and wants to play basketball. And for the second example, an apple pie requires 3/4 cups of sugar. If Emily wants to make 5 apple pies, how many cups of sugar will she need? So first what we're looking at is 3/4 cups of sugar. And that's equal to 1 apple pie. Now if we want to make 5 apple pies, that means we also need to have 5 times as much of sugar. So here is the setup. 3/4 times by 5. Now going back to the word problem, we have 3/4 times 5. And when we have a whole number multiplied by a fraction, we need to convert the whole number to a fraction. So 3/4 will multiply by 5/1. Anytime we are converting a whole number to a fraction, we simply add the denominator of 1 underneath, and it will remain the same value, but we change it to a fraction. So this way, we can simply multiply across. So 3 times 5 is 15. 4 times 1 is 4. And now what we have is the improper fraction, as the numerator is greater than the denominator. So now we want to see, out of the 15 that we have in the numerator, how many of equal groups of 4 we can divide that into. So if we take 15, divide by 4, it will give us 3, with a remainder of 3. So that means we have 3 whole, and the remainder of 3 would be in the numerator, and then 4 as a denominator. So that means we need 3 3/4 cups of sugar. Now for the third example, Joseph has 12 comic books. Of the 12 comic books, 1/4 are superhero comics. How many of his comic books are superhero comic books? So in this case, Joseph has 12 comic books. So what we have here are 12 comic books, and 1/4 of them are superhero comic books. So we have to multiply it by 1/4. So the setup is 12 times 1/4. And whenever we have a whole number that converting to a fraction, we add a 1 underneath the whole number, just like before. Then we're going to multiply by 1/4. And by looking at this, we can also see that we could simplify before we multiply. as the 12 and the 4 can both be divided by 4. So 4 divided by 4 would become 1. 12 divided by 4 would become 3. So now we just need to take the 3 times by 1 equals 3. And 1 times by 1 equals 1. So the answer is there are 3 superhero comic books. And if we look at this, if you mark them as 3 of them as superhero comic books, we can see that they are 1/4 of the 12 comic books. So that's 1, 2, 3, and 4. And that confirms it, as we have 4 equal groups of comic books are superhero comic books. So these 3 examples are how you would multiply fractions involving word problems. In this video, I'll be going over dividing fractions word problems. The tip of the lesson is when we are splitting and separating something into equal groups, we divide. We are going over 2 word problems with scenarios when we needed to divide fractions. For the first example, Joe has 3/5 of candies left. He is sharing these candies between 4 kids. What fractions of the candies will each kid get? When looking at this type of problem, the first thing that we want to look for is whatever that is being divided or split up into equal groups will need to go first. In this example, what's being shared are the 3/5 of the candy, so this will be 3/5. And how many equal groups are we dividing them into? As we can see from the example, there are 4 kids, so we're dividing between 4 kids. So we'll divide by 4. So that would be the setup for this question. And if you want to look at it from a visual perspective, we have 3/5 of the candy. So 3/5 of the candy would be about this much of the candy remaining. And what we're doing is dividing among 4 kids. So we're going to take the 3/5 and divide among 4 kids. So it would look something like this. And this is equal groups of 4. And we want to find out how many candies does each kid get. So essentially what we want to do is we want to find out how much does each kid get. So that's the setup. 3/5 divided by 4. So going back to the word problem, 3/5 divided by 4. When dividing a fraction by a whole number, we need to first convert a whole number to fractions so we can divide them. And 3/5 need to divide it by 4/1. Whenever we are converting a whole number to a fraction, we will add a denominator of 1 underneath it, but that doesn't change the value of the whole number. It still remains 4, as 4/1 is still 4. So now we have this 3. Now we have a fraction dividing by a fraction. So the next step, we would need to keep, switch, and flip. So keep would be 3/5, so we would keep that. The division would switch to multiplication. And the 4/1, we would need to flip. So 1 goes on top, 4 goes on the bottom. It will become 1/4. And that's how you divide fractions by fraction. So now we can multiply across. So 3 times 1 is 3. 5 times 4 is 20. Therefore, our answer is 3/20 of the candies were received by each kid. Now for the second example, Thomas has a rope that is 12 feet long, and it is being cut into 1/3 pieces. How many pieces will Thomas split the rope into? So first thing we want to look at is what are we trying to divide here? Based on what we see from the word problem, the rope is what we are trying to divide. And how long is the rope? Well, it is 12 feet long. So basically from the visual side, you can see we have a 12 feet rope, and we want to divide them in 1/3 of a foot, like so. And there'll be many more. And we want to know how many of the 1/3 feet are there. So to do that, we would take the 12 feet, divide it by the 1/3 of a foot, and that will give us number of pieces of rope. Okay, so now we have the setup, so we can go ahead and divide. So we have 12 divided by 1/3. So dividing a whole number by a fraction, we need to first convert the whole number to a fraction. So 12 here. So what do we do when we need to convert a whole number to a fraction? We would add a denominator of 1 underneath it. And that will still remain 12, but it's 12 over 1 now. Then we're going to divide by 1/3. And now we have the setup ready. 12 over 1 divided by 1/3. The next step is to divide the fractions by using keep, switch, and flip. So 12 over 1 is what we keep. Then the division will become multiplication. And then we will flip the fraction, 3 over 1. And now we can multiply across. 12 times 3 is 36. 1 times 1 is 1. So that means there are a total of 36 pieces, which Thomas will split the rope into. So these are two word problems that involve dividing fractions. The first one takes the object and split into equal groups, where the second one takes the object divided by the size of the equal pieces to get the total count of pieces that will be divided into. And we use keep, switch, and flip whenever we divide fractions. In this video, I'll be going over dividing unit fractions by whole numbers. Here is an example. 1/3 divided by 6. Whenever we have fractions in the division, we want to use the rule keep, switch, and flip. And how do we do that? Well, we'll first convert the 6 to a fraction. So the 1/3 is already a fraction, so we can leave that as it is. Now 6 will be equivalent to 6 over 1. When converting whole number to a fraction, simply adding the 1 in the denominator will not change the value of the whole number. So now we have 1/3 divided by 6 over 1. The keep, we would keep fraction, which is 1/3. We would switch the division for multiplication. So this one we will switch. And then lastly, we'll flip the second fraction by the denominator going to the numerator and numerator going to the denominator. And so if we rewrite, it will look something like this. 1/3 times 1 over 6. Now we just need to cross multiply. 1 times 1 is 1. 3 times 6 is 18. So our answer is 1/18. Now to visualize this, we have a cardboard, and 1/3 of this cardboard we need to divide into 6 sections. So the 1/3 is illustrated here, and the 6 means that we need to divide it in 6 sections. What is the fraction of the 1 unit divided here? Now if we complete and divide them all into equal pieces of 6, since this is 1/3, this will be 2/3, and this will be a whole. And so you can see that if we were to divide them all exactly the same as this, we would have 1, 2, 3, 4, 5, 6, and that's 6 here, that's 6 here, that's 6 here. So 6 times 3 means that there's total of 18 units divided. And this 1 unit is 1/18. So as you can see, that is the same answer as we've gotten previously when we use keep, switch, and flip. Now let's try this one. 1/6 divided by 4. Okay. Using the keep, switch, flip method, we would keep this, we would switch this, and we would flip this. So we would keep the 1/6, change the division to multiplication, and to flip 4, this is 4/1, and if we were to flip, it means it'll become 1/4. So then we would cross multiply 6 times 4, 24. And that would be the answer. And now we are going to move on to the quiz problem. And the problem is 1/5 divided by 3. Now feel free to pause the video as you work on this, and I will be back in about 10 seconds to reveal the answer. Okay, I'm back now. Hopefully, you've used the method of keep, switch, and flip and kept 1/5, switch division to multiplication, and converted 3, which is 3/1, and that becomes 1/3. Then you cross multiply and got the answer 1/15. If you got 1/15, then you've mastered this lesson. In this video, I'll be going over dividing whole numbers by unit fractions. So let's jump right in to our first example. 6 divided by 1/3. So the important thing to remember when we divide fractions is that we need to keep, switch, and flip. Okay, so we keep by keeping this number. Switch, we will switch the division to multiplication, and then we will flip the numerator to the denominator and denominator to the numerator. So if we rewrite, it will look something like this. 6 times 3/1. And now we convert the whole number to a fraction. You can always put a 1 in the denominator as it won't change the value of the whole number. And that converts it to a fraction. So 6/1 times by 3. 6 times 3 is 18. And 1 times 1 is 1. So the answer we have is 18. And for visualization purpose, you could imagine 6 boxes and you need to divide them in the groups of 1/3. So 6 divided by 1/3, I'm going to go and rewrite this so you can see it clearly. So each of these boxes will be divided in groups of 1/3. 1/3 will look something like this. That's 1/3. And that's 2/3. And that's 3/3. So that's a whole. And then we would literally do it the same way with the rest of the boxes. Now after you do that, how many of these 1/3 do you end up with? So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 of them. That is the exact same answer as when we use keep, switch, and flip. So this is one way where you could kind of verify that you've done the problem correctly. Now let's try this one. 4 divided by 1/6. Now we're going to do the same thing where we're going to keep the 4. Now we're going to switch the division to multiplication, and then we're going to flip. So 6/1. And then we're going to change the whole number to a fraction. And now we can multiply across. 4 times 6 is 24. 1 times 1 is 1. And the answer is 24. Now to see it in action from the visualization, we have 4 boxes like so. And this time we're going to do 1/6. So that's 1/6 here. The drawing may not be perfect, but I think you get the idea that it's basically 6 equal pieces per box. And we'll do the same here and here. Here. And now we're going to count how many we are left with. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So the answer would be the same as if we divide the fraction and using keep, switch, flip. And now we have a quiz question for you. What is 8 divided by 1/4? You may go ahead and pause the video, and I'll be back in 10 seconds to reveal the answer. Okay, I'm back. Hopefully, you've used keep, switch, flip, and keep the 8, changed division to multiplication, and flipped 4 and 1 like so. Then convert the 8 to a/1, cross multiply 32/1, which the answer end up with 32. Then if you get this correct, great job, you've mastered this lesson.